1448 count good nodes in binary tree. The question says, given a tree, return the number of good nodes in this tree. And the number of good node is defined here. A node is good if the path from root to x, there are node nodes with a value greater than x. Okay, so imagine yourself, you're at some node in between. For example, 4. How do you know you're a good node? Because none of your parents or predecessors has a value greater than you. 3 is smaller than 4. And for 5, both 3 and 4 are smaller than 5. So 5 is good node, 4 is good node too. Now this question is reduced to, during traversal of a tree, when you meet each node here, determine by our definition here if this current node is a good node. If it is a good node, add it to count. Then we're going to return count finally. So we're going to declare a class variable called count here. This is what we're going to return in good nodes function. And we're going to have a DFS function here to traverse the tree. Now comes the most significant part of this question. How do you know you're a good node? Do you need to know all the values from your predecessors? You just have to get the maximum value from your predecessors. And you compare yourself to that max value. If you're greater than that max value, then you can make sure you're a good node. And there's no way for a node in a tree to search upward. However, during our traversal, we could pass down the maximum value we've seen so far to our children, which means in this function DFS, we're going to pass down some max value in our argument. Like all recursive functions, we're going to give terminating condition here. And then we're going to do something for current node. Finally, we give the subproblems to our children. In our question, base case is going to be if node is equal to null here. So if the node is null, we simply return. Then as we said before, in current node, we're going to compare node value to max. So if max value is smaller than node.value, we're going to do count plus plus because we have found a good node. Before we dive into children's code, we also need to do one more thing, which is to update our max, because in this case, we've seen node.value greater than max, which means for our children, my value in this level is going to be the max for my children. So max is equal to math.max. Now we can safely code for children. So we call left and call right. Before we execute this function, we also need to fill arguments for DFS function. So DFS is going to start from root, and it's going to take the max value root.value. If you ever wonder why, let's take a look at this example. Please note, given this question, in any tree, root itself is going to be a good node because 3 is not greater than 3. Okay, seems like we need to fix the logic here. It's max smaller than or equal to node.value. So if we give 3 here, 3 is indeed smaller than or equal to 3. So we do count plus plus. And then for our children, they're going to know the max value from our predecessors is going to be 3 here. This is why we use root.value. Okay, let's run this real quick. So in our solution, time and space complexity are both going to be O of n because in the traversal, we visit every node one by one, and every node gets visited by one time. During this traversal, our call stack for this DFS function is going to be n levels. So it's also going to be O of n space complexity. Okay, before this video ends, I want to ask you one final question to see if it confuses you. So for example, in this tree, if this node is not 1, but it's 100, is it possible that your node 5 mistakenly thinks its predecessor's max value is 100, resulting in node 5 not being a good node? The answer here is no, because in our DFS function, max value is given as an argument, which is going to be given to 5 by node 4. No matter what its left child is, 4 is always going to give max value 4 to 5, not 100, not 1. And since this function doesn't have a return type, there is no way for node 1 or 100 to return its own value or whatever it has in its own level. Okay, so this is this question.